Good morning, good afternoon, and good evening to everyone joining us from all over the world. Thank you for joining us today to learn more about how AI can be integrated into mining operations to achieve successful outcomes. My name is Bettina Venner. I manage the Industry Capability Network in the Department for Trade and Investment, and I'll be your facilitator for today's webinar. Today we have 4 speakers who will share their insights and new technologies for the use of AI in the mining sector. After we've heard from each of our speakers, we will have a Q&A session, and please use the Q&A box to submit your questions. Bit of housekeeping before we kick off. Firstly, this webinar will be recorded. This allows those who have missed it to watch it at a later date. The recording will be uploaded to the Department for Trade and Investment's website. And secondly, there will be a poll which will pop up on your screens at the end of the webinar, which will allow you to provide any feedback you may have. All feedback is welcome and encouraged. I'd now like to introduce our first speaker, Dr. Zygmunt Szpak, Executive Director at Insight via Artificial Intelligence. Zygmunt has a PhD in computer science from the University of Adelaide and has worked at the intersection of artificial intelligence and challenging industry problems at the Australian Centre for Visual Technologies. His industry contributions include the automated production of geospatial information from satellite imagery, automatic object detection and tracking in video, algorithms for scalable classification of massive data sets, and conceiving and developing an innovative handheld wound assessment device that takes 2D and 3D images of chronic wounds to monitor wound healing objectively. Zygmunt's leadership position at the Australian Institute for Machine Learning gave him deep insights into issues that hinder AI adoption and deployment. Organizations face many challenges, and these differ depending upon where they are in their AI journey. This realization led him to co-found IVAI, Insight via Artificial Intelligence, with a vision of helping humans and machines work smarter together. Thank you, and over to you, Ziggy.
Thank you very much. So I'd like to explore a question today with you. How do we want AI to transform work and the workplace? And I think this question is of fundamental importance in the mining equipment, technology, and services sector, because the mining industry employs such a large workforce with diverse roles, and we really need to think about what the future of work would look like for our employees. Notice how I posed the question. I said, how do we want AI to transform work, not how will AI transform work? And the reason I do this is that I want to emphasize the agency that we all have in determining exactly how this AI will play out. It is going to be the principles, practices, and decisions we make when we adopt AI and the change management we put into place that is going to determine whether AI is something we look forward to or whether we look to with apprehension. So we founded IVAI to help organizations adopt AI. And the purpose on the next slide is that we want to help organizations become organizations whose policies, practices, and decisions derive from systematic, but crucially ethical and practical use of artificial intelligence. And in order to achieve this mission, we've spent a lot of time thinking about how AI is transforming jobs. We came to realize that AI is not really about replacing jobs. It's about transforming tasks that people perform. And sure, there are some tasks that will be eradicated. We call this work eradication. It involves replacing repetitive human tasks such as data capture or quality assurance tasks. But AI also comes in as a kind of work augmentation. This is when AI teams up with people. A good example in mining is suggesting where to drill for mineral exploration. An AI system can do that nowadays. We also speak about work intensification. This is when AI takes over the most mundane elements of work, leaving only the complex and often highly interpersonal to be performed by a human. A very cogent example of this is a chatbot, which might be able to answer a variety of different questions, but every now and again, it has to escalate to a human in order for the person to be able to answer it. So very few people think about how AI transforms tasks, but even few organizations think about how AI actually affects workers. So we thought deeply about this, and we came to the realization that AI kind of takes on 3 archetypes or 3 personas. An AI system can become a kind of director, or conductor, where it restricts and recommends information or actions to its users or workforce. Another way you see AI is a kind of evaluator, where it evaluates how workers perform tasks and assesses their behavioral patterns. And keep this in mind when you hear from resolution systems and the way the AI system assesses how people drive trucks. And another way an AI system comes into play is as a kind of judge. And maybe putting a very positive spin on this idea, you can imagine an AI system that is there to detect safety violations, such as not wearing appropriate safety attire when entering restricted areas. Many mining companies are using these kinds of vision systems to detect the people wearing helmets, for example. Now, what happens when you don't think about how AI affects workers? Well, you end up with something that we call the naive AI adoption paradigm. And this paradigm is best construed as a kind of sandcastle. It looks really beautiful, it sounds great, but it doesn't have solid foundations and it cannot stand the test of time. This philosophy is characterized by 4 traits. The first one is that every challenge an organization faces is seen as purely a technical problem that demands a technical solution. As a consequence of this, you often find that people are seen as fungible units of labor that you can optimize over. You'll hear the mantra, all you need is lots of data. And oftentimes the sole criteria for success are measured across 2 dimensions, time and money. But we founded IVAI to be a counterpoint to this rather empty philosophy, because we think that real AI adoption requires a human-centered approach. So we speak about the human-centered paradigm of AI adoption. And it's fundamentally different. And I will just give you a few highlights for how it's different. So first is the realization that human actors and human actions form an integral component of the system's operations and goals. Everyone is a someone and not a something you can just optimize over. And the reason for this is that ultimately, people actually seek autonomy, mastery, and development in the workplace. We go to work not just to earn money, but to actually thrive as people. The workplace and work itself serves as one of the most important social channels through which humans can flourish and human dignity can manifest. And the crucial realization when you start bringing technology into focus is that when you actually introduce an AI tool into the workplace, it implicitly or explicitly occupies a position on the social structure. People respond to technology. People change to behavior in response to technology, and you have to be aware of that to manage that change properly. So what goes wrong when you don't do that? What happens if you proceed with the naive approach? Well, you end up what we call the risks of naive adoption. So what can happen is that this conductor, instead of being conductor, turns into a sort of puppet master AI, where it's very constricting. So you can see this happening when, for example, you have an AI system that schedules shifts for workers, and ends up with the very fragmented shifts for people that are actually not conducive to their well-being, but they optimize some kind of criterion that you build into the system. Similarly, the evaluation becomes a problem because people start seeing, might, for example, disagree with how they're being assessed by the AI system. They might feel that their performance should be better than it's being assessed. And they start asking you questions such as, well, on what basis did the AI system give me such a poor score? Or they might want to contest it, and you haven't put into place any kind of policy to deal with that. And finally, the judge can be seen as a sort of overbearing big brother. And the surveillance that you put into place can be almost perceived as a sort of overreach by the organization to the privacy of the employees. And this whole, as consequently putting all of this together, you can create an environment where you actually create a lot more stress than you intended. So our philosophy ultimately is about changing this. So we think that the starting point is that you have to recognize that work is a social relationship. And once you do that, you realize that you need to establish proper oversight and governance structures to monitor the degree to which the tools simultaneously facilitate self-realization for the worker on the one hand and professional output on the other. We want to say yes to improved productivity, yes to reduced cost, while simultaneously saying yes to the room for self-mastery and self-realization in the workplace. So AI adoption is really a long and winding road, as the next slide shows. You need to navigate this forest, and there's a lot of decisions that you need to make along the way. And we bring our expertise to help you navigate that process. And we speak about what we call the AI journey. And we see our organizations that we partner with as being at different stages of the journey. So some organizations are seekers. They They know they want to adopt AI, but they're really not sure where to start. They haven't even thought about how it could affect their workers. They need an education of what AI actually is, and they need to be guided through the process of what's going to happen next. And oftentimes, they then become what we call explorers. They're able to actually formulate a problem they want to attack, and they want to maybe prototype it or proof of concept it. And so we do work in that space. And if that passes, well, then they become travelers because they decide, you know what, we really believe in this technology. We want to integrate it now. And there's a lot of work involved in actually figuring out how to integrate this into existing infrastructure. And finally, what can happen is some organizations that use AI for a while want to become trailblazers. They start wondering, well, what if we could do this or that with the AI system? And this is where there's room for research and development. And so ultimately, what we're here to say is that, in the next slide, as I'll show you, you can reach out to us. You can find out more about what we do. We are here to hear about your journey into AI and mining, and we are here to help you along that journey.
Great. Thank you for your insights, Ziggy, on the things that companies need to take into account when they are looking at introducing AI. Now we'll move on to our second speaker, Kim Eales from Resolution Systems. And Kim is standing in for Tom Corley, who's unfortunately unable to attend today. Kim is a founding member of Resolution Systems and has over 13 years experience in the mining sector as both an operations leader at Rio Tinto and in implementing MaxMine. Operationally, Kim's core focus had been fleet optimization, operating for reliability, tire life improvement, and operator engagement to sustain performance. Unusually for an operational mining leader, Kim's career began in human resources, working in multiple industries before finding a home in mining with Rio Tinto. Kim then transitioned from human resources to a mine operational leadership role. Kim has a passion for turning operations around, and his focus has always been people-centric. Over to you, Kim.
Fantastic. Thanks, Bettina. Can you hear me okay, just to double check? Yep, awesome. And Zygmunt, that was a really cool intro. I had a massive smile on my face as you were going through your presentation, because it definitely touched, I guess, my background and where I've come from as well. Do we have a video to play as well? So we do have Tom, who can make it virtually, so I'll let this one play for a couple of minutes.
Resolution Systems integrates business improvement and powerful operational analytics to add value to asset-intensive industries, including mining and energy. Our founders have extensive experience in the energy sector, mining and business improvement industries. And our company is built on a 15-year legacy in business improvement and data-intensive process optimization. We began optimizing the fuel efficiency of mining trucks, but in 2015, we realized that to make a serious impact, we'd need to optimize all of load and haul operations, so founded Resolution Systems. To deliver the results, we developed MaxMine, our flagship product and the next generation of operational technology, available via a SaaS subscription model. Production variation in mining is high, typically 20% from shift to shift. The product works by monitoring asset data at very high resolution, delivering unprecedented process measurement, disaggregating the causes of variation and enabling improvement. It's delivering productivity increases of 20%, resulting in fuel efficiency improvements of up to 8%. For companies, MaxMine offers the chance to gain new business insights via complete and accurate data sets, totally free of human error or manipulation. We're proud to have worked with a range of key customers to help them reach their goals. Contact us to learn more about MaxMine and how it could change the way you run your operations.
Fantastic. So I'm done now. No. So really, just want to say a thank you, Bettina, and then we'll jump into it. So as Tom mentioned, we were founded in 2015, but we actually first tapped into our first mining truck in 2010. We currently have 45 employees. The majority of those are based in Adelaide, and we've now captured and processed over almost 4 million hours of operational data. Next slide, please. So taking a quote from Mike Tyson, everyone's got a plan until they step in the ring and cop a punch in the face. And fairly similar for me today, but after hearing Zygmunt's presentation, I think there's a lot of synergies in what's already been discussed today. So what I'm going to do is I'll divert a little bit from my original presentation, but take you on a little bit of my journey and Tom's journey as we progress forward. So from my side as an operational lead, what I found when I enter any operational site is that there's a multitude of possibilities. Everybody's got great ideas, and they can see the benefit that's going to be associated with those ideas. Next slide, please. But what we find is that sometimes people just don't know which idea they need to approach and how to approach that idea, how to get the most value out of that specific idea, and therefore, how do you unlock that value? Next slide, please. And here's an interesting piece. So we've talked about technology and that it's growing, that that the technology is booming, and the progression and evolution of that technology has had a fairly steep curve. But this is the mining productivity index over the last almost 20 years. And you can see that there's been a fairly sharp downward turn, and we're starting to see a gradual trend heading back up. And really what we're looking to do is unlock genuine value. Next slide, please. And what does unlocking value look like? So people think that, if I've got lots of data, that is genuinely big data, but you've got to make sure that you're focusing on the right areas and that you're looking for the right sort of outcomes. Next slide. And what we've found, and this is another recent report. So this is for 2020, and these are the priorities by mining companies across the globe. And so their number one priority, which has been sort of pretty much number one for the last few years, is essentially maintaining a license to operate. But you'll see in there that productivity and rising costs is in number 3, and then also digital and data and innovation also sit within their focus areas, which all sort of combine together from our perspective to look to deliver genuine value within the mining sector. Next slide, please. So I've touched a lot on the industry and where we've gone, and I think the previous presentation was definitely a great segue into what we are doing, and it is really focused around giving genuine feedback that is able to reduce the variation between operators through effective feedback. So that can include a little bit around gamification, but you want to make sure that when you are applying this, that it is applied in the right manner, because it can have that impact of the big brother element, and people can actually have a negative response to this if it isn't implemented into an operation effectively. And so what we're doing with the rollout of MaxMine, and we'll touch on our special source in a little bit, but we're enabling operators to take ownership of their performance and the site's performance as well, and seeing significant improvements in that. And what you're seeing here is a visualization of a 700-meter section of haul road that prior to us, which is on the left-hand side, the site was sitting below the mine plan targeted speed, and then after implementing our operator efficiency process, we're getting up above the mine plan. Next slide. And if I now take this into the payload space and look at how we can help operations implement effective payload performance, well, this is what we typically see. So, and this has been my experience as an operational lead as well, is that you tend to have these projects that get implemented and championed. You get a fairly good increase and a bit of stability there for a little while, but over time you see a little bit of erosion of that performance, and that tends to drop off because focus is lost and it's not given that same sort of attention. And so in the next slide, what you'll see is that we tend to see sort of this a very large spread in the payload delivered to trucks, and then once we've rolled out the feedback mechanism and operators are engaged in the system and they can manage it all themselves, then we see the next slide is a nice tightening of that histogram, and really the delivery zone is improving significantly, and we can then start to shift fairly effectively. Next slide, please. So what is our special sauce? We look at not just the technology piece, and we've got a lot of cool tech that sits in the background, but the people element is exceptionally important, and that's already been touched on, as is the process in which you go about doing that. So we have all of the data from the vehicle by operator, and so we're actually able to grab engine speed, the load that's on the back of the equipment, vehicle position, all of the key parameters that are important to us. In fact, we actually pretty much get everything off the machines, and we're agnostic to equipment types. And we use machine learning to automatically classify what the operators are doing. So for load unit operators, as an example, we can see if they're loading a truck or dumping a load into the back of a truck, or if an operator is in a truck and they're in the hauling cycle. There isn't a requirement for an operator to push a button. So we're taking the human input, which is very unreliable, and so you can't mislead the results by gaming the system. And so that way, operators tend to trust what we're doing, and so KPIs are far more consistent and reliable. And so by doing this, we can drive lasting operational change across the site. And so on to the next slide. If you're looking to reach out, you can contact me on the details that you see there. Otherwise, hit our website, yeah, Rick will be on the call to answer any questions, as I've got to attend my little girl's graduation in about half an hour or 20 minutes. So thank you so much.
No worries. Thank you, Kim, and all the best with that graduation. And it was great to see the impact of the human element and how important that is and how you take that one into account. So I'd like now to introduce our third speaker, Dr. Vinay Sriram. He's General Manager Engineering at IPACS Australia. Vinay joined IPACS in 2010 and is currently the General Manager of Engineering. He's responsible for leading the acceleration of growth in the company's mining business. Vinay started his career with the Defence Science and Technology Organisation, and he later worked as a postdoctoral fellow at Imperial College London and as a research fellow at Harvard University. Thank you, and over to you, Vinay.
Thank you, Bettina. So IPACS is an Australian technology company with a proven track record in innovation and technology across mining, energy, and defence. So we established our operations in Australia in 1997. We have 37 customers to date, and we are a globally focused technology company. We as a company specialize in intelligent industrial Internet of Things, predictive analytics using machine learning and AI, and actually in the combination of digital twin, IoT, and machine learning. I shall tell you about the power of combining all of these and the value that we're delivering to one of the world's largest digital twin companies. We are always committed to delivering real value to our customers through our disruptive technologies. Next slide. So we have a long history of innovation in IoT. We ourselves started off as a condition monitoring company. In 1997, we were the first company to deliver a 48-channel time-synchronized online condition monitoring system. In 1999, we received what is considered to be gold standard in the marine and offshore oil and gas industry, that is accreditation from American Bureau of Shipping, Lloyd's Registers, and Det Norske Veritas. Since then, until 2015, we have been continuously improving our product to such a stage that we are now able to integrate our IoT systems and our condition monitoring systems with industrial and automation platforms at site. This is through our innovations and integration into our data acquisition system, the Profibus OTC, Modbus OTCP, the onboard historian, and an OPC server. In 2019, we launched our partnership with Dassault Systems. Next slide. So we signed our agreement with Dassault on the 20th of March, 2019. We are jointly working on defense and mining projects. As you know, Dassault are a key partner to Naval Group on Australia's future submarine program. And not only that, Dassault actually view IPACS as an integral part of the digital twin, in fact, the next generation of the digital twin. So for the first time, IPACS condition monitoring systems will collect the data and feed data back into the CAD drawings. These are the drawings that designers of Australian future submarine or the ships and frigates use to further enhance and refine their drawings. So it closes the loop, and it is seen as a very powerful partnership by Dassault Systems. In fact, it is the only global technology partnership they have signed of this kind. Next slide. I shall now present 3 case studies where I'll demonstrate the value that we've delivered back to the mining companies. The case studies are very different in nature, in the type of commodity the operators or the owners operate in, and the value that we've generated. The first is with an iron ore miner who wants to eliminate the problem of unplanned breakdowns at their mobile crusher due to millions of dollars in lost production. The second is a miner who wants to expand their operations but is unable to do so due to inefficient secondary resource estimation. And the third is with a company that wants to get rid of unnecessary expensive maintenance on their trucks. Next slide. So in the first case study, the miner was facing unnecessary unplanned breakdowns of their mobile crusher. This customer was using mobile crushers that churn out in total 1,500 tons of iron ore per hour. These have a single point failure. When a screen bearing failure occurs, it produces 0 tons per hour. And it takes them on average 7 hours to replace this. So you multiply 7 times 1,500 times $135 per ton, which is the cost of iron ore today. You will arrive at the price of $1.4 million in lost production. Next slide. We implemented an online condition monitoring system to automatically detect these problems and provide early warnings. We also identified many maintenance practices that could be improved. In total, we were able to completely eliminate the problems at this of unplanned breakdowns at this mobile crusher. Next slide. Here's an example where in the red circle, I'm showing an alignment issue which was causing a bearing fault. The maintenance crew only replaced the bearing but did not address the alignment issue, and hence in the second circle, the bearing fault re-emerged. So we worked with the customer to improve the quality of maintenance by correcting this alignment issue so that problems such as this do not occur at all. So on the x-axis, we've got time, and on the y-axis, we've got amplitude on this graph. Next slide. So the second case study is with Ronfos. Ronfos are a phosphate mining company owned by the government of Nauru. They have been mining phosphate on this island since 1904. They were planning to undertake a big expansion project, but their problem was they did not really have a good understanding of the secondary ore reserve. And their investors rejected whatever model that they presented. And so they were planning for a $50 million mine expansion. Next slide. The original approach they took was they used LiDAR to generate a digital terrain model, rasterize this image using QGIS, and the geologists actually downloaded these images, manually drew polygons around the phosphate ore, exported it back into QGIS, and finally mapped it for visualization. The IPACS system, once again, downloaded the data using QGIS. We used machine learning to automatically classify the ore, build the polygons, pixelate it, and export it back into QGIS and MapTech. Next slide. The original approach took them months at end to generate a low resolution model. The customers were only able to target polygons that were 20 meters apart, while our technology was able to generate all the polygons required to designate the phosphate ore in less than 5 minutes. It was a high resolution model. It was independently validated by the mine geologists and MapTech consultants, and finally approved by Samsung for the expansion. Next slide. So here I've got one example of how we've done this. So on the left-hand side, we've got the island of Nauru. In the middle, we've got a figure of a single tile of the mining area. And on the right-hand side, we've got all the polygons that I've generated, or that we've generated using our algorithms. Next slide. So this is actually a reference letter from the CEO of Ronfos, where he openly recommended our technology because it was so successful. We ended up winning work in Philippines from Philfos, which is a major manufacturer at Ronfos. And in fact, Ronfos have now engaged us as an EPC for the $50 million mine expansion. This is a clear example where by delivering value, we earn the trust to become an EPC contractor at site. Next slide. The third case study is a very interesting case study. It is with the world's largest contract miner. During the mining downturn, they were sick of unnecessary, unrequired maintenance. So they were operating Caterpillar 793 trucks. These trucks are fitted with 2 planetary gearboxes at the rear end. They're very, very expensive to rebuild. They cost $180,000 per rebuild on a time-based schedule of every 3 years. We went with the mining company to the OEM site where they ripped apart a gearbox that had arrived from the customer side for refurbishment. There was no problem at all. They put it back and sent it back. This was an unrequired maintenance that they were carrying out. They wanted to move from time-based maintenance to condition-based maintenance. They were aspiring for a 25% life extension. Next slide. We implemented our technology and we received real-time data across the entire differential and the planetary gearbox, which is what you can see in this slide. Next slide. And we were at 30% life extension, we were able to provide early warnings for gearbox problems. Mind you, this gearbox still had 6 months worth of life left in it. So on the left-hand side, we've got the time waveform for a normal gearbox. In the middle, we've got the time waveform for a gearbox with a broken gear tooth. The high impacts are due to metal-on-metal impact within the gearbox. And on the right-hand side, we've got the broken gear tooth. So in this way, we worked with the customer to identify these problems, as well as extend the life of these gearboxes and move from time-based maintenance to condition-based maintenance. Next slide. We have received many awards for our technology. The I Awards are one example. And we've actually got a remote operations center that was launched by the previous treasurer of our state, Honorable Tom Houston-Tarnas, and we've got various customers that we serve throughout the world. With that, I shall complete my presentation, and this is the last slide. Yep, and hand you back to Bettina. Thank you.
Great, thank you very much, Vinay, and those case studies certainly brought it all to life. Now I'd like to introduce our final speaker, Andrew Harris, Mining Analytics Consultant at Consilium Technology. Andrew Harris spent 22 years of his career at Scantech, a company which designs and manufactures high-tech conveyor-mounted elemental and moisture analyzers for the global mining industry. He joined AI company Consilium Technology in the mid-2018 to build a mining analytics business unit and lead a team of data scientists and a software engineer, helping customers and fellow METS companies get the most value from their data through data analytics and machine learning. Over to you, Andy.
Thank you very much, Bettina. Hi, everyone, and thanks for hanging on for the last speaker of the day, being me. Before I get underway and tell you about a couple case studies of AI in mining, we're just going to roll a video that will just give you a bit of an overview of the mining analytics team and what we do here at Consilium. As a well-established artificial intelligence company, Consilium Technology has strengths in data science and software engineering to help organisations make better decisions. Our team of Australian scientists and industry experts use AI to extract actionable insights from your data to discover new opportunities for your business. We perform research and develop deployable AI solutions across a variety of industries, from defence to agricultural, manufacturing and of course mining. We're proud to have worked on some major projects, including prospectivity heat mapping for IGO. This sped up the process of finding ore bodies within a 30,000 square kilometre exploration area of Western Australia's Albany-Fraser Range. We also carried out process optimisation for BHP at Olympic Dam to help them better understand their complex process. We have key customers and markets in Australia and overseas, plus a number of quality approvals and awards. Contact us today to learn how applying AI to your data can change the way you do business. I said it better myself, actually. Really quick rundown of Consilium Technology. So we're an Adelaide-based artificial intelligence company. Our strengths are in data science, focusing really on machine learning, which is a subfield of AI, and of course software engineering. So there's machine learning model development using customers' data, and then there's actually wrapping that in software that allows the model to be deployed. And a little infographic there just really shows that a trained machine learning model depicted there by an AI chip can take in a lot of data feeds from all over the plant, and basically output simple information that can be used by human operators to improve decision making so that they can take the right action. Next slide, please. So I'll talk about a couple case studies, and I mentioned them briefly in that little video, but I'll tell you live a couple case studies. This one focusing on process optimization for BHP at Olympic Dam. They basically had real quality issues with the copper cathode coming from the solvent extraction and electrowinning tank house part of their process. And they also had a lot of data, about 10 years of data, for which they labelled when these problems were occurring. Set we were able to download from their historian data set. So really what this project required was my colleague and I to go up to site and really speak to the problem owners, the people up there responsible for the quality control of the plant, the senior metallurgist, and really gain a solid understanding of the data, the process that the data comes from, and of course understanding what their problem is, which we did first before we just launched into playing with numbers. And basically we were able to visualize their data in ways that they could have never imagined using Excel worksheets. Some examples are just shown there on the slide. That's my colleague Ben Schultz and me in the electrowinning tank house. It was 43 degrees that day, and the face mask looks very pre-COVID. Looks very COVID, but it was actually pre-COVID. So we're able to visualize the data in 3D and really find patterns that helped us select features or really input variables which were interesting to use in the training of machine learning models. And we're able to actually predict fairly accurately when these process upsets would take place based on some key indicators. And we were able to reasonably well predict when those key indicators would become upset. So it was a bit of a three-stage problem that we were solving there. But that graph in the bottom showing predictions in red against measurements in blue for solvent conductivity. When that spiked high, dendritic growth would often happen hours later. And you can see that we're able to predict those high spikes really well. And importantly, not just having a machine learning model which can make predictions based on inputs, but also being able to explain the AI, to interpret the models, and which features really drove them to drive outputs high and low. So we performed a feature importance assessment on the models which performed well, which enabled us to pick which elements were causing problematic highs and lows, and really help guide BHP and help their understanding of the plant to avoid those conditions which would increase the risk of the process upsets. So this wasn't AI deployed in terms of a model being then put on site to tell them what to do in a live setting, but it resulted in a detailed report. And I will add that during the project, we had a meeting every fortnight with them, just to ensure that our machine learning work stayed on track and in step with their understanding of the metallurgy and the process there. But we gave them a detailed report that really was AI's interpretation of how their plant was operating and what was causing upsets. So if you can just go to the next slide, please, Ben. Here's another one, and I presented on this recently at IMARC, and I know I've got to go pretty quick. This is actually a minerals exploration problem where, maybe next slide, there's a 30,000 square kilometre area, which is that dark purple diagonal patch within that red box in the Albany-Fraser Range of Western Australia, where IGO mining company headquartered in Perth is looking for nickel, cobalt and copper ore deposits, similar to the Nova mine that they currently operate there. And if you go to the next slide, we used data they already had, geophysics, namely ground gravity and airborne magnetics, actual measurements plus the first vertical derivative of each, which is more sensitive to shallower features in the ground, and also geochemistry data, 9,000 drill holes, lots of samples collected along the segments of those drill core samples. And basically what we ended up doing was setting up a supervised machine learning problem here where each hole was labelled as either being prospective or not prospective based on its geochemistry. And of course, we had associated geophysics at each point. If you just go to the next slide, please. Just pictures here of geophysics measurements. Next slide. You can see the drill rig top left and lots of core samples being brought to surface and sorted for preparation for laboratory sampling. Very slow and expensive process drilling. If you just go to the next slide. So really the aim is to avoid pattern drilling, which is kind of like stabbing in the dark, hoping you're going to find something. Briefly jump on my soapbox about alchemy. It looks like alchemy, just like alchemists of old attempted to turn base metals into gold. We don't want to be practicing alchemy where we just ask customers for data, just send it to us and hope that we find little gold nuggets of information or insights in that data. It's not possible. We really need to gain first a deep understanding. If you just go to the next slide, mate, thanks. So applying AI with a deep understanding means going and facing the customer, whether it be Zoom or in person. We're lucky to do it in person before COVID hit. Pre-processing the data in a meaningful way to really upsample to a higher spatial resolution. As I mentioned, labelling each drill hole as prospective or not, 1 or 0 binary label, and then setting up a supervised learning training session. So if you just go to the next, please. So ultimately, once we had trained a machine learning model which could associate the 4 layers of geophysics with likelihood of prospective being high versus low, we're able to then feed that model each 10-metre grid point across the entire 30,000 square kilometre area. And this map on the right is really the output of the model. This is the part of the map that we can show. The rest is a bit too sensitive, which is really, I guess, showing how useful the map is. It highlights in yellow very high confidence of there being prospective rock there, which is really a mafic and ultramafic rock, which may contain those trimetal sulfides. And purple is very low confidence, and you can see some features there which will help IGO, is already helping IGO target their drilling program so they're not just stabbing in the dark, literally in the dark patches. You just go to the next slide, please. And that's it. So there are a couple good examples of mining companies having a lot of data, trying to interpret that data with people and people's collective experiences, and really augmenting that with some clever science. And that's really it. Thank you.
Great. Thank you, Andy. That also brought it to life with those case studies. And now I invite any questions from the audience. Please do so by posting your questions in the Q&A box on your screen. If we don't get to all your questions, we will follow up with you individually. But I see there's a very specific question that's come up first. So I'll ask that one first. Vinay, I reckon this one's for you. So the question is, can you furnish your condition monitoring systems as, and now there's some technical terms that Vinay, hopefully you know what they mean. So HW and SW appliance for plug and play modules with minimum fault configuration, so we can sell your product and systems to many of our Indian customers.
Yeah, absolutely.
Vinay.
So hardware, the HW and SW are obviously hardware and software.
Oh, right. Okay.
Yes, absolutely. You know, we've advanced our data acquisition system to such a level that we have Profibus over TCP, Modbus over TCP, and OPC server. We've got a partnership with OSR Soft to integrate our data acquisition systems with the historian. So we've got an OPC UA server and a protocol on our data acquisition system that allows interoperability at the SCADA level. And yeah, so absolutely, you know, it's completely off the shelf. And the main thing with our data acquisition system, it's multi-channel, time synchronized, which is a big thing in condition monitoring. And the second thing is we do auto tracking, so we are able to measure vibration with respect to speed, temperature, and so on. Because when the speed changes, obviously the vibration signature changes as well. And that's an important parameter to capture.
Great. Well, he provided his contact details, so we'll pass those on to you. Yeah, so he's asking if we can follow up further by email. Now, other questions that have come in as well are, what in your experience, and maybe I'll start off with Ziggy on this one and then move on through the rest of the panel as well. So in your experience, what do you think have been the greatest challenges for your customers when adopting AI?
That's for myself, is it, Bettina?
Well, it's to start off with Ziggy, but then you as well. Maybe Vinay, if you start, and then we move on to Ziggy, and Rick Morgans is standing in for Kim Eales, so he can hopefully answer that one as well, and Andy. So Vinay, yep, go for it.
Yes, so I'd like to answer that question by actually reflecting on one of the statements made by the previous head of innovation at Rio Tinto, Andrew Shook, at the Australia 3 event organized by Colin Farley. This was a big mining event where Andrew Shook made a very interesting observation. He said that it is absurd to think that the mining industry is risk averse. Everything that the miners do is about risk. What miners are not interested in is in compound risk. They do not want to further expose themselves to risk by using unproven, unreliable technology. So by showing that there is real business value and by using reliable, proven, and field deployable solutions, absolutely you can gain the confidence of the miners. And that is the biggest challenge, that they're just very risk averse when it comes to unproven technology.
Great, thank you, Vinay. Ziggy?
Yeah, sure. So look, I think the way I see this is that these AI technologies are going to keep increasing. You're going to have more and more different kinds of AI tools being deployed on the workforce. We've seen some examples today, but the pace is really just accelerating, and there are a lot of new possibilities emerging. And I think that the real challenge is going to be around figuring out exactly what those new tasks your workers will be and managing that. Because as you hand over more and more responsibility to AI decision systems that are meant to make decisions for you, make suggestions for you, you are implicitly taking away the human autonomy decision making. And you need to figure out, if you want to avoid compound risk, for example, like Vinay mentioned, you have to think about what processes and procedures are going to put in place, given the fact that you're now having these black boxes make decisions for you. So there's a real drive towards explainable AI and also the human element. And I think that's where the challenge is. People haven't figured out how to actually adopt this technology in a way that's going to reduce that compound risk.
Great, thank you, Ziggy. Now, Rick Morgans, and if I can introduce Rick really quickly. Rick is also a co-founder of Resolution Systems. So, Rick, are you there?
Yes, I am. Thank you very much. Yes, so I guess at Resolution Systems, we have a slightly different approach in that our software is very customer focused. So the customer might not realize that they're actually using internally artificial intelligence or machine learning. So the part that I work in our team is essentially the help desk, but it's bigger than the help desk. It's where our customers ask us questions, and we use data science to interpret the questions for them. And so we might use some machine learning in that to do some classification or some finding these questions, finding out what's of value to them, reporting back, and then eventually, if it's of high enough value to all of our customers, it'll make its way into the software. So we have a different approach, I guess. We're not trying to sell machine learning or artificial intelligence directly to the customer. We're selling an outcome which is improving the operations of your mine, and a bottom line is dollars there. Does that make sense?
Yeah, so it's basically a customer pull rather than a push.
We don't push things on for no reason. So
right. And then Andy, any comments on the greatest challenges you've experienced for companies adopting AI?
Yeah. I think I only wish to add to the comments just made and really echo the fact that generally we're dealing with a pull from customers who are almost at their wit's end sometimes with the data. They're unable to solve the problem they need to, or improve whatever they're doing manually by looking at the data. They make a huge investment in the data, and that's really what we need to craft machine learning models from. So we haven't had any issues with customers kind of engaging us delivering and then not adopting. So, yep.
Oh, great. And I'm just looking at the time, so we'll finish off with one last question for each of you. And Andy, I'll start off with you. What international markets are you interested in, and what might the distribution model look like? Is it distributors, partnerships? What are you interested in from an export perspective?
Yeah, good question, Bettina. Certainly interested in, we're really focusing our mining analytics efforts on minerals exploration and anywhere in the world which there are exploration teams collecting data and struggling to find buried ore bodies. We'd be very keen to talk to you. And also process optimization, I would say. We've done a couple good projects, or four good projects now in that space. So I'd be really interested in speaking to any mining companies or even METS companies that just need a complementary AI partner, dealing with those types of challenges. We're not really into the predictive maintenance field so much with our focus at the moment. So, yep. And channels, I would say, ideally, as I have had many conversations recently over the IMARC platform, mining company or exploration company in Turkey are keen to talk to us next week. So wherever you are in the world, we'll deal direct with you, and you can contact us at consilium.technology/MAIT, M-A-I-T, Mining Artificial Intelligence Technology, MAIT.
Great, thanks, Andy. Okay, who shall we go with next? Rick?
We already operate, we sell a software as a service, software and hardware as a service. So we have a monthly fee, and our clients rent the hardware that we install on the mining trucks to service that. We already have operations in South Africa and Ghana, and we're looking, I guess, at any miner of a certain. I guess we have a sweet spot in contract miners, but we're active in Australia and Africa, and have had contacts in South America and North America as well. We've had a couple of trials in North America, but it hasn't been adopted yet. Basically anywhere where the miners want to improve their productivity with a system that locks in that value and closes the loop.
Great, thank you, Rick. And Ziggy?
Sure. I mean, I think that at us, we're kind of thinking about predominantly trying to help mining companies actually figure out where the opportunities are internally. So as was mentioned already, there's a lot of like services being provided where you can pull this component, that component. But I think that the true value in this technology is going to come when organizations are able to internally really understand what it is capable of, able to form teams around which they can think of new ideas, think of new opportunities. In many ways, every organization has common problems, but many organizations have very unique problems as well. And so our kind of interest is very much in partnering with people who really want to start on the journey, the seeker stage that I spoke about. I'd say that's where we're currently most interested in.
Great, thank you. And then Vinay.
Yeah, Bettina, we are very interested in export. We've been exporting our technology. In fact, there was a time when we were exporting more technology than servicing the Australian market. We've been accredited by gold standards in industry like ABS Europe and Lloyd's registers and so on. So Europe, Asia, the Middle East, we've been exporting. With your introduction, we've even formed a partnership with the South African company, as you know, Bettina, and in Kazakhstan, the Takman Group. We are very open to partnerships. We're partnering with some of the biggest companies like Dassault Systems, as well as smaller companies. Growth options, I think they're going to be significant growth options in Western Australia for us. We're already working with a major phosphate mining company up there, and a Salt Lake Potassium Company, Callium Lakes. We're working with them to use drones on modeling the water plants and so on. So there's a lot of activity in WA, which traditionally tends to be the hub of iron ore and so on. So yeah, we're very keen on partners and working directly with mining companies.
That's great. And that pretty much brings us to time. So I'm going to wrap it up there. Thank you to our speakers, Ziggy, Kim, Vinay, and Andy, and also Rick, who joined us right at the end. That's been a great engaging discussion this afternoon, and I think everyone will have a lot to take away from today. So that concludes today's webinar. Thank you for joining us for our final METS webinar. We hope you found the webinars useful. Just a reminder that all the webinars have been recorded and are available on the Department for Trade and Investment website. Remember to stay online briefly to fill in our short survey. And the conversation doesn't have to end here. Feel free to reach out to any of our speakers today, and also to my colleague Chris Lim, Business Development Manager, Minerals and METS within the Department for Trade and Investment. He's here to assist you, and his details are listed on the closing slide. So thank you and goodbye.